And we're back. um, we're back at Kristen Grant, and we are here with Dr. Swayze from the University of Washington. She's an assistant professor at the School of Global Health. So in part one, we talked about some of her projects and some of the difficulties in implementing and researching her current projects. So now we have some other questions. I think a couple other questions. So we need to employ, we talked about employing people to go behind the scenes and build these machine learning models. So here our students are in the data science and analytics program. So what would you recommend a student in such a data science analytics program study? So what tools or what should they be good at, in your opinion, to become a data scientist?
I think students should actually like working with data, first of all. If you don't like working with data, then it doesn't make sense to become a data scientist. Statistical and machine learning techniques are important things to learn to understand the theoretical aspects of it and understand how they can be applied, these methods can be applied to data. Learning how to code and code well in a way that people can reproduce your work or use your work without having to talk to you to explain every single line of code. Other things are if you're working with data, you want to understand the data. And that means understanding where the data is coming from, understanding what are some of the limitations in the data source that could affect the results that you're having and the inferences that you can make from the data. Visualization is a big deal. So if you can learn how to visualize your data well so that people can better understand it, that would be really, really useful. And I mean, in general, it's always good to be able to write well. So you can express the things that you're working on to different audiences, not just academics, but people who do not know the subject matter well. In terms of tools, I think for data analysis, I usually use R and Python, and I think a lot of people use that. For visualization, R is good. Python is also good, but lots of people are using D3 and Tableau these days. Data storage, MySQL, something I like, but different people use different databases, Mongo. Also just, having a tool set to be able to use different types of machine learning algorithms, network analysis, statistical modeling, all those things, very important.
Wow. So we're learning some of those tools now in this program. I like to push Python on my students. So out of all those hard skills, so you need to learn how to code, like you said, and that you gave a great list of tools. Are there any soft skills besides the communication? So you work with a lot of medical data or data about diseases. Are there any any issues there, ethically, that people have to deal with?
Yeah, I think, for example, data from Twitter is considered to be open because people are actually allowing you to be able to get your data. But this data can be very sensitive because you don't only have information about where people are at a certain time. You can track back to where they actually live and their communities, who their family members are, if you're really intent in doing that. And so there have to be better regulations of how we use this data. And also, I think people need to be educated about what they're actually revealing online and how that could affect them on a daily basis. So I think it's very sensitive, most of the data that we use. And people have privacy concerns about this, but it's kind of difficult to deal with it because these individuals are actually putting this data online. And so it's, how do you make the decision of saying this data should be treated this way or that way when it's publicly available?
Yes, good point. So we are getting some good information from the web that people put out there publicly. So out of the things that you are allowed to discuss and allowed to talk about, what are some of the surprising conclusions, in your opinion? from the research that you've done so far?
One of the things that we found that was really interesting was looking at how the foods that people were reporting that they were getting sick from Yelp data, we compare that to the foods that were being reported in foodborne outbreaks from the CDC, and we found this to be very similar. That was very surprising to us. We weren't expecting the data to capture so much when we compared the two different data sources. We also, another study we did was to look at hospital usage, so how often people were using hospital parking lots. And we did this with countries where not everyone has a car. Compared to the US, car ownership is a lot less. But we were very surprised to see that just looking at hospital parking lot fill rate, that could be a very good predictor of disease in the community. Yeah, so that was 2 examples.
Yeah, big. Those should have big impacts. Just those conclusions. Very interesting. So, what are some open areas of research? What are you looking at next, or what do you think are what's the next frontier for your research areas?
So one of the major challenges with the data we get from the internet, for example, data you get from Twitter where people say they're sick with something, is the fact that you don't know if they're actually sick with that disease. So a major challenge is data validation. There's been at least one study where someone actually collected medical records for people that use Twitter, and they was able to track and see how often they tweet and whether people in the networks were also tweeting about disease. And so that was kind of like a validation study to say, okay, yes, people that are sick actually tweet. But figuring out how to validate this data is a really big challenge. The other thing I'm interested in is how to integrate these data sources with data that we already have. So if we know that a disease is being influenced by different environmental factors, so if there's a lot of rainfall, then something happens and then there's this outbreak, how can we incorporate the data that we're getting from Twitter in real time with some of those environmental factors to either just track how diseases are spreading or make predictions of how those spread?
That's really cool. So I hope some of our students maybe can go to a PhD over in the University of Washington and study some of these.
That'd be nice. That'd be nice.
So well, I want to thank you for your time. Thank you for discussing your research with us and some of your interests. And on behalf of the class, thank you.
Thank you.